Now let's take some time to look at how to rationalize when we have two terms in the denominator. We're still going to be multiplying the denominator by something that eliminates the radical, but we have to use something called a conjugate, which is when we have two binomials with the same term but opposite expressions. You'll notice that this is actually the factored version of a difference of squares. If we multiply this out using our distributive property, we see that the second and third multiplications are actually going to be opposite signs and end up canceling out, leaving us with a squared minus b squared. So if a is an expression with a radical and or b is an expression with a radical, those radicals will get canceled by the squared. This allows us to rationalize the denominator when we have two terms instead of one. So let's take a look. So if we have two terms, we multiply by the conjugate. In this case, the conjugate will be the same two terms, but we're adding instead of subtracting. And this entire expression equals 1, so it's not changing the value of the expression. So we'll just apply our distributive property. In our numerator, we get 5 root 3 plus 10. In the denominator, we end up getting the square root of 3 squared, which will simplify, the 2 root 3 and negative 2 root 3, which will cancel out, and then negative 2 squared, which will simplify. Notice how a was the square root of 3, b was 2, and we're just squaring both of these values to get 3 minus 4. That's a squared minus b squared. So when you're multiplying a number by its conjugate, you are more than welcome to write out all of the distributive property, but there's a little shortcut with this formula as long as we understand what the conjugates are doing. And you're going to see me apply that to the other methods moving forward. Now, if you get lost, I encourage you, do the complete distributive property. You'll still get the same solution. It'll just take you a little bit longer. So we have 5 root 3 over 10, or 5 root 3 plus 10, over 3 minus 4, which is negative 1. The other thing I want to talk about here is how we deal with simplifying that negative 1. It pops up time and again, and I just want to emphasize how we can write the solution, because we don't like leaving negative 1 in the denominator. It's a little unsimplified. So we consider that we're taking this numerator and we're dividing it by negative 1, which is the same as multiplying it by negative 1. We have the fraction equivalency property with negatives. So this entire expression is negative, so we can write it negative inside parentheses, or we can distribute the negative inside the parentheses to get rid of the parentheses. Either of these is an acceptable notation. Unfortunately, a lot of times I'll see a lot of students put the negative in front but forget the grouping symbol, and that is incorrect. Either of these two representations are acceptable. Here we're going to go ahead and write our conjugate. So our denominator is 3 square root 2 minus 4, the same terms but the opposite operation. Distribute in the numerator, we get 6 root 2 minus 8. In the denominator, we can distribute all 4 times, but we can also remember that our shortcut is going to be a squared minus b squared. A squared is 3 root 2. B is 4. So a squared minus b squared. Now when we simplify this denominator, 3 root 2 squared, we have 9 times 2, which is 18, minus 16, leaving us with a denominator of 2. Now, considering how to simplify this fraction, we'll simplify it the same way we did rational expressions in the previous chapter. All terms have to have a common factor. We have a term, we have a term, and we have a term. We can consider the numerator and think, okay, can I factor out a GCF? I can factor out a common factor of 2. And since now I have a factor times a factor, we can eliminate these factors and simplify it to 3 root 2 minus 4. We'll see some other examples where we can't simplify. I want you to take note of the difference between them. Here our conjugate is going to be root 5 plus root 3. The numerator we're going to distribute all 4 multiplications. We'll have the square root of 30 plus the square root of 18 plus 2 root 5 plus 2 root 3 over a squared minus b squared. Square root of 30 can't reduce. Square root of 18 is 9 and 2, so that simplifies to 3 root 2 plus 2 root 5 plus 2 root 3. None of these are like radicals, so we can't add them. And then our denominator is 5 minus 3, which equals 2. We cannot simplify this any further. Even though we have common factors here, there's no common factor of 2, there's no common factor of 2. Therefore, since all terms do not have a common factor, that is as much as we can simplify. Last example here, our conjugate is 3 root x minus root m. We'll distribute 6 root mx minus root m squared over a squared minus b squared. Here we can eliminate the square and the radical. Here we'll have 9, and then square root of x squared is x. 6 root mx minus m over 9x minus m. We don't have a common factor between all the terms. These two have a 3 in common, but the others don't. These have an m in common, but these two don't. So that's as much as we can simplify.